The last video we covered all of A-level integration briefly in 20 minutes, and today we're going to go into one of those topics a little bit more. We're going to find the indefinite integral of 1 over 1 plus x squared. This is a standard result, so I'm pretty sure it's in your formula book, but I want to show how this is derived using integration by substitution, so that you can get an idea of how to choose your substitutions. So the idea with substitution, remember, is to write this x as a function of u, or write u as a function of x, either way around, whichever one works, in such a way that we get some cancellations, which makes this easy to integrate. And this 1 plus x squared looks like some identities we know, and the one in particular that we're going to use is that 1 plus tan u squared is equal to sec u squared. And the beautiful thing about that is the derivative of tan u is sec squared u. So we're going to get the cancellations that we want, so that's what we go for. We substitute x is equal to tan u, and then we get the derivative of x with respect to u is equal to sec squared u, and that means dx, you can take it like this again from the chain rule, but this isn't literally true, but anyway, it's not that dx isn't really equal to anything, but you get the point. And then 1 plus tan u squared is sec squared u, so this whole integral becomes sec squared u du squared u. Well, that's the integral of 1 with respect to u, and the integral of 1 is just equal to whatever we're integrating with respect with, and that in this case is u, and then we'll add our constant of integration, so this could be 7, 100, 7,000, whatever, because when differentiated we'll just go to 0, right? And u when differentiated with respect to u would go to 1, so this is our result. And now we want to write this in terms of x, so well, if x is equal to tan u, then u is equal to arctan x, and then we'll add the same constant integration. So that's a pretty simple example of integration by substitution, but most integrations by substitutions are simple once you get the substitution right, which is the tricky part. It takes a lot of practice, but you've got to just use a little bit of foresight as to, what's this going to differentiate to, could that be helpful, and trial and error too. And the more you do it, the more you'll start to pick the correct substitutions. We'll be doing loads more examples of this on this channel, as it's quite a fun topic, and also can be challenging. One last thing to note is, when you see this in your formula book, it will have some constants involved, and maybe you can go through and work out if you put, if you had ax squared or whatever, how that affects this result. But for now, that's it for this video. I hope to see you in the next one. Over the next week or two, we'll be covering lots on integration, so more substitutions and integration by parts, some integration using partial fractions, some differential equations possibly, and yeah, please like and subscribe, and I hope to see you in the next one.